Hello student, welcome to the class of physics. In this video, we'll see some MCQ questions on the concept of oscillations. You know that in the oscillation, the first concept is very important, that is the linear simple harmonic motion. And in the linear simple harmonic motion, the restoring force is directly proportional to the displacement, but the direction of force is always directed towards the mean position. So depending upon this concept, there are different numericals. We'll see one by one from our booklets. The first questions, the figure is given. 3 springs are there. 2 springs with spring constant K1 are parallel to each other, and this parallel combination is connected with another one second spring with spring constant K2. Then depending upon this system, calculate the resultant value of spring constant. So we'll see, initially calculate the value of spring constant for the parallel combination. The force constant for these two parallel combination of the spring is remains same, and the Kp is equal to K1 plus K2, so its value is equal to 2K1. Then this parallel combination in series with second spring, that is K2 with spring constant K2. In case of series combination, we just write down 1 upon Ks, so resultant force constant in series combination 1 upon Kp plus 1 by K2. You know that Kp is equal to 1 upon 2K1, so put the value of Kp, it is equal to 2K1. Then, so simplify it, reciprocal of this, because this is 1 by Ks, so Ks is equal to 1 upon 2K1 plus 1 by K2, and its inverse minus 1. So this is the resultant force constant for the combination of this 3 spring. So the correct option for the question number 1 is option number B. The correct option is option number B. In the 4 MCQ, or in the 4 options, in 4 options there is some mistake, -1 is not there, so be careful. The correct value of this resultant force constant is Ks is equal to 1 upon 2K1 plus 1 by K2. Next question, question number 2. In this second question, the given average energy in one time periodic time of the simple harmonic oscillator whose amplitude is A and angular velocity is omega, means only the value of amplitude is given, angular velocity is given, then calculate the average energy. According to the definition, the average energy is equal to integration of energy with respect to the integration dt and integration. This is the formula to calculate the average energy. Put the value of this integration of this dt with respect to the limit 0 to t is 1 upon t. So put the value of total energy, this u, in this equation we get 1 upon 2 m omega square a square. M is the mass of the block, omega is the angular velocity, capital A is the amplitude, and this is cos square omega t minus phi. Then average energy, because the value, integration value of this cos square omega t is 1/2, so we get 1 by 4 m omega square a square. So the resultant average energy is 1 by 4 m omega square a square. So correct option for this question number 2 is, this is 1 upon 4 m omega square a square. Next one, question number 4. In the question number 4, equation is given, displacement equation. So x is equal to 2 sine of 10 pi t plus pi by 2. Compare this given equation with the standard equation of simple harmonic motion. X is equal to a sine of omega t plus pi. When you compare it, we get the value of amplitude, angular frequency, as well as periodic time. Put the value of omega 10 pi, so we get 0.2 second. Then the question number 4, calculate the maximum velocity, maximum speed. We know that maximum speed is equal to a omega, so amplitude is equal to 2. Put the value of omega, so maximum speed is equal to 25. So for question number 4, correct option is option number C, that is 25. Similarly, question number 5. In the question number 5, the velocity after time t second is, for the same equation, calculate the velocity for the time t is equal to 5 seconds. So x is equal to sine 10 pi t plus pi by 6. Time is given 5 seconds. So put the value of small t is equal to 5 seconds in the last equation. Simplify it. Finally, we get x is equal to 1 centimeter. So you have to calculate the velocity. We get x, then calculate the acceleration. Minus omega square x, 10 pi is the omega square into 1, it is 100 pi square. So v is equal to, put the value, v is equal to omega under root a square minus x square. Amplitude, so put the value, it is omega is 10 pi in the bracket. This is a square minus x square. Be careful, there is one mistake here. This small a is the amplitude, it is not 100 pi square, amplitude is 4. So 4 square, this is 2, so 2 square, it is 4 minus 1 square. So it is 4 minus 1, so it is under root 3 10 pi. So correct option of this question number 5 is option number D, that is 10 under root 3 of pi. Similarly, question number 6. In question number 6, what is the question? Acceleration of the particle at time 5 seconds is, same t is given, calculate the acceleration from the last given equation. Omega is equal to 10 pi, x is equal to 2 pi, 10 pi t plus pi by 6. Acceleration equation minus omega square x. So put the value of t as a 5 seconds. So acceleration is equal to minus omega square. So it is 10 pi square. So same from the last question number 5, we get the displacement is equal to 1. So finally acceleration is equal to 100 pi square. So for the question number 6, correct option is minus, there is a minus sign, 100 pi square, that is the option number D. Correct option is option number D. Next one, question number 7. In the question number 7, what is the given things? In question number 7, two springs are there with spring constant K, and these two springs are parallelly attached to the rigid support, and to the common terminal there is a block of mass M. So these two terminals, these two springs are parallel. So by using the parallel combination, the resultant force constant Kp is equal to K plus K, that is the twice K. So in this question, find out the frequency. So frequency is 1 upon 2 pi force constant upon A. Put the value of force constant for this combination, it is twice K upon A. And second condition is given, if one spring is removed, then its frequency, this force constant is remains same because one spring is removed. So f dash is equal to 1 upon 2 pi under root K upon M. Find out the ratio of these two equations. F dash upon F is equal to 1 upon under root 2. So the value of frequency when one spring is removed is equal to F upon under root 2. So correct option for the question number 7 is option number D. Next one, question number 8. In question number 8, one diagram is given. A particle is performing simple harmonic motion. Its kinetic energy, its k, varies with the time t as shown in figure. This is the expression of kinetic energy varies with respect to time t. Then, according to this diagram, there are four conditions are given. Four options are given. First option, period of the oscillation of the particle is equal to capital T. So this capital T is not the period because that require time to complete the full sine wave is the capital T. So first option is not correct because this is the condition. Second one, the potential energy U of the particle varies with the time t. So second option is correct. Potential energy of the particle varies with respect to time t. Why? The potential energy is given 1/2 m omega square x square, and the total energy is the potential energy plus kinetic energy. Finally, total energy remains constant 1/2 m omega square a square. So correct option is option number D. Then question number 30. In the question numbers depends upon the concept of ratio of intensity. So what is the given things in question number 30? Ratio of intensity is given. It is 4:1. I1 by I2 is equal to 4:1. Difference of loudness is described in decibel. Then calculate the difference in between the loudness between maximum and minimum intensity when they interferes. So maximum and minimum intensity difference. So we can calculate the ratio of maximum to minimum intensity ratio. Put the value of I1 and I2 in this equation. It is equal to 2:1. So finally we get it is 3 square. It is 9. Difference in the loudness. So equation of loudness 10 log of I max upon I naught for the maximum loudness and for the minimum loudness. By using the law of log, we get 10 log of I max upon I minimum, and I max upon I minimum is 9. So log of 9 is 2 into log of 3. So it is 20 log of 3. So correct option for the question number 30 is option number B. Question number 31. A wave number k is given 2 pi upon lambda and it is equal to 0.6. In question number 31, the equation of vibration of the string fixed at the one end vibrate in the third harmonic is given. So equation is given. According to this equation, the third harmonic, the lambda is equal to lambda by 2 is equal to pi upon 0.6, because what is the equation? Y is equal to 2 sine of 0.6x cos of 500 t pi of t. So in a third harmonics, what is the vibration? 3 lambda by 2. So put the value of lambda by 2 from the last given things, pi upon 0.6. Finally we get the answer. The length of the string is, this is the length of the string, small l is equal to, actually there is a small l, so length of the string is equal to, in a third harmonic, 3 lambda by 2. Put the value, we get 15.7 centimeter. So the correct option for the question number 31 is option number D. Next one, question number 35. In question number 35, two sound bodies producing progressive waves, which is given, y1 is given and y2 is given. This is the value equation of y1, this is the equation of y2. Then one situated very near to the ears of the person who will hear. So you have to calculate the intensity, first one, then you get the value of frequency as well as the ratio of intensity, because all the options are given in terms of frequency and the ratio of intensity. So write down the n1 value. From this one, it is n1 is equal to omega 1 upon 2 pi, omega is equal to 400 pi, in the second case 404 pi. So we get this n1 and n2 is equal to 200 hertz and 202 hertz. So bit frequency is capital N, or N is equal to N2 minus N1. This is the difference between the two frequency of two sound waves. So 202, we get this bit frequency is 2 hertz. So 2 beats per second. This is the bit frequency. Then ratio of intensity, use the concept of amplitude. A1 plus A2 whole square for the maximum intensity and A1 minus A2 whole square for the minimum intensity. So we get it is 49 as to 1. So we get the two value, bit frequency as well as the ratio of intensity. According to this, we can find out the correct option. So for the question number 35, correct option is option number B, 2 beats per second in frequency, bit frequency with intensity ratio 49 as to 1 between maximum and minimum. So correct option is option number B. Next one, question number 49. In question number 49, the given things, the speed of sound through the oxygen at a certain temperature is 60 meter per second, and the speed in helium at the same temperature will be. So we can write down the equation of speed. V is equal to under root small, this is the gamma RT upon M. R is the gas constant, T is the temperature, molecular weight. So gamma for this oxygen and helium. For the oxygen, gamma value is 7/2 diatomic. For the helium monoatomic, it is 5/3. So put the value of this gamma of oxygen and helium in the equation of speed. We get these two equations. Then velocity ratio. Velocity for oxygen through the oxygen and velocity through the helium medium. Simplify it, we get velocity through the helium medium is equal to 60 into under root this value. So we get the velocity of this speed of sound through the helium medium is equal to 180 meter per second. But in the core option, there is no any correct option. So we'll see the next question, question number 54. In question number 54, what will be the time period of the displaced body of mass M? So in question number 54, the system of 3 springs is given. 2 springs are in parallel and 1 spring is in series with the parallel combination of 2 springs. So to calculate the periodic time, we know that periodic time is equal to 2 pi under root M upon K. So first one, calculate the value of K equivalent, that is the equivalent force constant for this series and parallel combination. So initially this force constant for the parallel combination is 2K. Then K equivalent for this whole system is in series combination K into 2K upon 3K. So it is twice K upon 3. Put the value of K equivalent in this equation, we get the time period, and the correct option for this question number 54 is option number C, 2 pi under root 3M upon twice K. Next one, next question number, there is a one figure is given, and this figure of this diagram consists of 5 to 6 questions. So 25 question to 29 question. So this is the two sine waves or simple harmonic motion. One is starting from this 5 and second one is starting from the origin. So this is half amplitude, half of the amplitude. At time t is equal to 0, and second one at time t is equal to 0.05 second. Then from this figure, we get the amplitude of this both the wave is equal to 10 millimeter. So 10 millimeter is equal to 10 into 10 raised to minus 3 meter. The equation of the wave traveling along the positive x-axis. So we get this y is equal to a sine of kx minus omega t plus phi. This is the equation of wave traveling along the positive x-axis. Then case 1, when time t is equal to 0, x is equal to 0 centimeter. So y is equal to a sine of this minus kx term is equal to 0 minus omega t plus phi, and this is equal to a by 2, means half of the amplitude. So it is equal to a by 2. So we get sine of this angle minus omega t plus phi is equal to 1/2, and when this sine value is 1/2, when this theta is equal to pi by 6 at time t is equal to 0. Second case, when time is equal to 0.05 seconds, and in this case this x value is 1 centimeter. So x is equal to 1, put this value here, then k is equal to 2 pi upon lambda. What is lambda? Lambda is the wavelength. According to this we get the wavelength for second equation, it is equal to 2 meter. So this k is equal, lambda is equal to 2 meter. So we get the value of this k is equal to pi. Then y is equal to a sine of pi minus omega upon 20 plus phi, but sine of pi plus theta is equal to sine theta. So this pi value get cancelled. So finally y is equal to a sine of minus omega upon 20 plus phi is equal to 0. Simplify it, we get the angular frequency is equal to 10 pi upon 3. So frequency is equal to omega upon 2 pi. So 10 pi upon 6 pi. So f is equal to 5 by 3 of hertz. Next one, velocity of the wave is v is equal to frequency into the wavelength. So wavelength is 2, frequency is 5 by 3. So velocity of the wave is 10 by 3. Maximum velocity, Vmax is equal to omega a. Omega is equal to 10 pi upon 3 into the amplitude, that is 10 millimeter. Convert this millimeter into the meter. Finally we get Vmax is equal to pi upon 30 meter per second. Next one, that is the tension. Tension is equal to mu, that is the coefficient of friction, or you can say that this is the string of mass per unit length. This is the value of mass per unit length into v square. So put the value 0.25 into v is 10 by 3 square, so it is 20 by 3 Newton. So depends upon this calculation, there are 4 to 5 questions. So we'll see one by one. The first question is determine the speed of the wave. Question number 25, the speed of the wave. So what is the speed of the wave? We get the speed of the wave is 10 upon 3 meter per second. So the correct option for question number 25 is option number B. Its value is 10 upon 3 meter per second. Question number 26 depends upon the given diagram. Determine the frequency of the same. The frequency of the same is omega upon 2 pi, and this is equal to f is equal to 5 by 3 hertz. So correct option for this frequency is option number A, 5 by 3 hertz. Next one, question number 27, determine the maximum speed of the particle, and maximum speed of the particle is omega A. So omega is 10 pi upon 3 into the amplitude, so it is pi upon 30 meter per second. Pi upon 30 meter per second means correct option is option number C, pi upon 30 meter per second for question number 27. Next one, question number 28, determine the tension in the string. So tension is equal to, it is mu, what is mu? Mu is the mass per length into v square, velocity square. So mu is already given in the figure, 0.25 into the velocity square, 10 by 3 square, we get 25 by 3 of Newton. So correct option of this tension in the string is option number E. Then question number 29, determine the equation of wave. To determine the equation of wave, y is equal to a sine of, this is kx minus omega t plus phi. We get a is 10, then omega is this k is equal to pi, omega is equal to 10 by 3, and phi is equal to pi by 6. So put the value, all the values in the standard equation. Y is equal to a means 10 sine of kx minus omega t plus pi by 6. So for the question number 29, the correct option is option number C. So in this way, you can solve the different questions on the oscillation as well as wave. In the oscillation, the main concept is the linear simple harmonic motion, and in the waves, that is the equation of simple harmonic progressive waves. Progressive wave means there is a transmission of energy from one place to the another place. So there is a concept of kx. So similarly, you can solve the number of questions on this oscillation and the waves. Thank you.